Welcome biologists. Today we are looking at some maths within biology. Really, really important that you can do these skills because it's worth 10% of your grades in your exam. Today we're looking at standard deviation. I highly advise and recommend this book. It's very, very good explanations and also talks through practices. So standard deviation, this is the spread of data around the mean. So as here you can see your mean, and I can have one standard deviation, two standard deviations, three standard deviations. Now we're just looking at the one standard deviation, the spread of data around the mean. Now the standard deviation is better than my range because my standard deviation excludes those extreme values that you may get at your extremities. This is your formula for your standard deviation. You do not need to learn this off by heart. It is provided in your exam, but you do need to be able to apply this formula. So here is another version of that formula. I'm going to talk you through how to calculate standard deviation for these particular values here. I've only got 4 of them. So the first thing you need to do is create a small table just like this one here, where you would have x, which is this value here, take away x bar, which is the mean of these 4 values, and then I'm going to square this number that I've got here. So first thing I need to do is calculate my mean, which I've done here, 8.75. What I then do is 7 take away 8.75 will give me minus 1.75. 4 take away 8.75 will give me this one, so on and so forth. What I then do is square that value. Now don't forget, a negative times a negative becomes a positive. So get a positive value. So if I do that all the way through that example there, what I then need to do is add up all my values in this column to get this one here, the sum of all these values. So if I add up all the numbers in this column, I will then get 67.75. Once I've got that value, I then need to divide my value here by n minus 1. N is the number of samples I've got. So I've got 4 samples here. So therefore, n minus 1 is 3. So I'm going to do 64.75 divided by 3. And that gives me 21.583. I then need to square root this to get my final standard deviation, which is like so. Now, you need to be able to do this in an exam, but the good news about biology is you can use a scientific calculator. So I'm going to talk through, I'll show you the slides on how to use this calculator first of all. So I'm not going to read through it, but you can have a go at that yourself, pause the video. It's really important we look at SX, not sigma x. SX is the sample deviation. And here again are the instructions for this calculator. So pause it and have a go at calculating standard deviation using the values on the previous slides so that you can get a good practice and make sure you can do it correctly. So here I've got some other values if you want to pause it again and calculate the standard deviation, which are going to pop up in a second. So if I calculate the standard deviation of these 2 particular data sets, what's really good about this is I can then plot my standard deviations on a graph as standard error bars. So here I have my mean value before exercise and my mean value of heart rate after exercise. And what I'm now going to do is plot on my standard error bars. So my standard deviation for before exercise was 5.64. So I go up from my mean by 5.64 and draw a line, and then I go down from my mean by 5.64 to draw a line down that one. I then do the same on the other side, but for the standard deviation value for this mean, which was 7.45. So I go up by 7.45 and then down from my mean by 7.45 to get those error bars. Now, error bars can tell you quite a lot about your data. If my error bars overlap, like they do in this particular image here, this area on the graph here overlaps between these error bars, there is no significant difference between these particular means. However, if I go back to my error bars that we were just talking about then, these error bars do not overlap. You can see there's area on the graph here that between the error bars where they do not overlap. And this means that there is a significant difference between these 2 means. Now, you need to be specific in your exam and mention what the means are, like I've done here. So you need to say there is a significant difference between my mean heart rate before and then after exercise. So the standard deviation can tell you quite a lot about your data, and you do need to be familiar with this in your exam. You do need to be able to plot data on a graph, and you do need to be able to calculate your data as well. So in this particular data set, as you can see here, my 2 error bars are overlapping. Therefore, there is no significant difference between my mean cell size between my cheek and my onion cells. There is a significant difference here. And here is another example if you want to give it a go. Guys, Good luck.